let's move to the fourth theorem. Right. The fourth theorem, again it's px over qx. Px over qx, and qx not equal 0, but px order equal to qx order. Both orders, p and q are known as polynomial functions. P order and the q order are z. As an example, you can write it like x cubed plus a over x minus b, x minus c, x minus d. No matter it's a linear or not, the main thing is you have to understand the order of the both numerator and denominator should be equal. That's the only thing, and we are not considering the denominator behavior. And if the order of these two are equal, then remember you have to put constant over here on the remaining constant. It's isolated constant k, and the others are coming with the same manner, just like the first theorem that we have discussed. X minus b, it's a over x minus b. Here it's b over x minus c, d over x minus d. This is the theorem number 4. So again I am repeating, in theorem number 4 we are focusing on the order of the both numerator and denominator, and the order is equal of the both polynomial functions, and if it is same, if it is equal, you have to put constant. You have to put only constant to here, unknown constant, and you have to find it as well. Over x cubed minus 1, this is the example I selected for the fourth theorem. So here x cubed minus 1 can be factorized into x minus 1, x squared plus x plus 1. And here you can see the orders are same. Then you have to put constant k, and here it's linear a over x minus 1, and over here x cubed plus x plus 1 is quadratic. Once if it is quadratic, you have to put linear part bx plus c over x squared plus x plus 1. Now I am taking a common denominator, x cubed x minus 1 x squared plus x plus 1 equal k times x minus 1 x squared plus x plus 1 a into the LCM, it's x squared plus x plus 1, and also bx plus c, which is multiplied by x minus 1, divided by x minus 1 x squared plus x plus 1. Here start cancelling, then you can write it x cubed equal k into x minus 1 x squared and bx plus c x minus 1. Actually here x minus 1 into x squared plus x plus 1, it's equal to x cubed minus 1. Therefore I'm just removing this and putting x cubed minus 1 plus. Right. Now you have to find the unknown constants. We have 1, 2, 3 and 4. We have 4 unknown terms. Right. Now I'm going to consider the coefficient of x cube. The coefficient of the x cube, which is 1 equal to k, then k will be 1. And the x squared coefficients, coefficient of x squared, here we don't have x squared, 0. Here also we don't have an A. Here it's B. A plus B equal to 0. And coefficient of, actually we can put x equal 1. Here this is going to 0 and also here going to 0. Then we can easily find the value of A. When x equal 1, here it's 1, here also 0. This is A into 1 plus 1 plus 3 plus here 0. Then A will be 1 over 3. Then B will be minus 1 over 3. Considering equation number 1. Right. We just need to find only Z. Right. To find the C, I'm considering the coefficient of x. Here it's 0. Here it's only A. Here it's bx into minus 1 minus b. Bx c into x is plus c. Zero equal A is 1 over 3 minus b is plus 1 over 3 plus c. Then c will be minus 2 by 3. So these are the unknown constants that we have: z, a and b, and k. Right. Now, time to interpret our final answer, which is x cubed minus 1 and it's a over a means k plus a over x minus 1 plus bx plus c is minus 1 over 3 plus 2 by 3 over x squared plus 6 plus 1. This is our final answer. Here it's k plus a plus bx plus c. Okay. 5. Theorem number 5, we are focusing px over qx, the same thing. Qx not equal 0 and the order of px is larger than the order of qx. The numerator order is a little bit greater than. But if you are comparing the order of these two, you will feel in this theorem, theorem number 5, the difference of the orders, the difference of the orders is 1. As an example, if it is x cubed, then the numerator should be x minus 1, x minus 2, something like that. Here the order is square, the 2, and the here order is 3, and the difference is 1. I'm taking an example, x squared, x minus x cubed is minus a, x minus b. Here the difference of the order is 1. Then what we have to do, previous theorem, our orders are same. If it is same, you have to put a constant. But here the difference is 1. If the difference is 1, you have to put a linear term like ax plus b plus c over, others are same, x minus a, and d over x minus b. But you have to remember, if the orders, the difference of the order are 1, the difference of the order is 1, then you have to put a linear part. If the difference of the orders is 2, you have to put a quadratic part. If the difference of the order is 3, you have to put a cubic part. So this is linear. The previous one, it was constant. Now it is linear, and the next step, the difference is 2, you have to put a quadratic one. The difference is 3, you have to put a cubic one. But the most of the time we have only this one and the previous one. They are not giving the larger powers of the numerator. So this is theorem number 5. Okay, let's move to example. Right. This is the example of theorem number 5. Here you can see the order of the numerator is third power, the order of the numerator is second power. The difference is 1. But actually you can factorize the denominator, it's x squared minus 1 means you have to write it like x minus 1, x plus 1. So all the time you have to convert into the, if it is factorized, you have to convert into the linear partials. Right. The difference is 1, you have to put ax plus b plus c over x minus 1 d over x plus 1. Now you can see the theorem and the example. We are focusing 1. Okay. Then now ax plus b, I'm going to multiply by both 2, then it's x squared minus 1 and c into x plus 1 t into x minus 1. Denominator x minus 1 x plus 1, these two getting cancelled, and you will have 3x plus 4 ax plus b x squared minus 1 cx plus 1 d x minus 1. Right. Now we have to find the constants. Right. Here once you put x equal plus 1, here it's 3 minus 3 plus 4 equal, here it's 0 and c into 2, 2z. 3 cancel and z equal 2. X equal minus 1, so minus plus 3 plus 4 equal to 0, whole thing 0. Here it's 0 and the d will be minus 2. And it's 6 plus 4, it's 10. 10 divided by 2 is minus 5. d is minus 5. Right. Now we found 2. Right. Now let's consider the coefficient of x cube. Here we don't have x cube, 0, and here we have a, then a equals 0. Now you just need to find only one, it's b. To find b, I am considering the coefficient of x to the power 0. Actually you can put x to the power square, x to the power 2, x to the power 1 or anything, but why I am taking x to the power 0, it is very easy to find, because x to the power 0 means only constant. Constant is only 4. The left hand side is only 4. The right hand side is minus b and plus c and minus d. C and d already found. 4 equal minus b plus 2 equal minus plus 5 now. So b will be 2 plus 5 minus 4, which is 3. b equal 3, a equal 0, and d and z. So now let's interpret our final answer. So the question was x squared minus 1